Hey, geometry kiddos, let's go over this. So I think what I'm going to do is go ahead and do all the odds. I'll probably end up doing maybe a couple evens along the way, just if they exhibit a different skill set that you need to use. So first, start off with number one. So we're looking here to see if things are similar. Now keep in mind what similar means. Similar means that the angles are the same and the sides are proportional. Okay? So we look here, and what we're looking at is see if this triangle right here and this triangle right here are the same. And basically what that means is that by similar, it means we could expand one of them to the other one. So the way we do that is we see whether or not we have a similarity process or a similarity rule. So the similarity rules we have are angle, angle, side, angle, side, and side, side, side. Now when we're talking about sides, unlike congruence where they had to be the same, here we're just talking about proportional. What do we mean by proportional? Means that the ratio of the sides between the two triangles is the same. So notice I went the short one here to the longer one, and the short one here to the longer one. We need to make sure that when we're doing, when we're setting up our similarity statements, that there's that continuity. If we wanted to, we could also, go 5 over 20, short to short, equals 7 over 29, long to long. Notice either way, when we cross multiply, we end up with 5 times 29 equals 7 times 20. So that's going to give us 145 equals 140. That is not true, so we can just say no here. Okay? So let's look at number 3. Now, number 3, we don't have any numbers. So if we're looking at our 3 possibilities for similarity, we don't have any side lengths here at all. So the only one we have is angle, angle. We know through the vertical angle theorem, sorry, took a second on that one, vertical angle theorem, that those two are middle. Whenever we have two lines that cross, they form vertical angles. And then the other key that helps us here is these arrows, and that means that the angles are, that means those two lines are parallel. So remember way back in first quarter, and I said you guys would be using this all year long. Well, here we are. Last day of school, still using it. So whenever two parallel lines are crossed by a transversal, we know their alternate interior angles are congruent. So we know because MN is parallel to GF, we know that angle N and angle G are the same. Okay? So that gives us angle-angle similarity. So now, and this is really important here. So this is, so we're going to put yes, angle-angle similarity. Is that necessary? Absolutely. Read the instructions. State if the triangles in each part are similar. Yes. If so, state how you know they are similar. Angle-angle. And then complete the similarity statement. So the similarity statement here, now we have LMN. So we go L to M to N, right? Now here we know that N needs to match up with G. Why? Because those two are congruent. So we know L is the same. So triangle L, F, G. So notice that puts G and N together, the two L's together, and then L and N are going to be congruent as well. So that's how you write down one when you know that they are similar. So number 5, a couple ways we can do this. So you can just start off 40, because the two triangles we're trying to prove are congruent or similar. This one and this one, right? The little one and then the big one. So we have 40 to 112 equals 41 to 112. Now you should be able to look at that and immediately recognize that they are not similar because those are two different numbers. Because when we sit there and cross multiply, we're going to be going 40 times 112 equals 41 times 112. And clearly those are going to be different numbers. So we're just going to go no. Okay, so let's look at the number 7. Find the missing length. The triangles are similar. So we know they're similar here. So we know that BCD is congruent or similar, sorry, to BKL. So that's going to help us when we set it up. So we have BC here, and we know that's going to match up to BK. So then BL and BD need to measure up. See how they're in the same order in the similarity statement. Now this is stuff that we learned a while ago, but you guys should hopefully still know it. And yes, I'm saying that with a straight face. So when we set this up, we're going to go the ratio of 18 to 12 equals 3 to x, x being, that's the question mark. But notice how we did the circle to that and this to this. How do we know that? Because BC is similar to BK, so they're both on the top there. Cross multiply, so we have 3 times 12 equals 18 times x. 36 equals 18. X divided by 18 divided by 18. 36 divided by 18 is 2. So the missing side is 2. Easy peasy. Same idea here. So we're going to go to the ratio. I'm going to do things a little bit different here. I'm going to go 28 to 8 equals x to 14. Notice that I went this whole outside part, that's UV right here, to this, and then this part right here to this. So notice the 28 and the x are in the same spot. Those are the long outside parts of the outside triangle. The 8 and the 14 are on the inside. And then we just cross multiply. So we're going to 8x equals, I don't have a calculator out right now, so I'm just going to go 28 times 14. It's 392. Divide both sides by 8, and we get x equals, into 39, that's going to be 4 times. It's 32. That's 72, and that's 9. So that's x equals 49. Okay. Brings us to number 11, solve for x and then determine the length of the missing side. Basically the same exact thing that we're doing now. So here we know, let's go over here. So here we know that 13 and 117 are going to match up. X minus 2 and 63. How do we know that? We can just look. So FG, that's right here. That's going to line up with MN. See how they're in the same spot? Meanwhile, HG, these two right here, is going to match with LM. So HG, LM, FG, MN. So if we set this up as 13 over x minus 2 equals 117 over 63, cross multiply. So we get 117 times x minus 2 equals 13 times 63. Now you'll have a calculator when you do this, and I have one, I just don't feel like, you know, honestly, it's like 4 feet away. So we're going to go 117x minus 117 times 2 is going to be 234 equals 8 and 19. So we're going to add 234 to both sides. We get 117x equals 1053. Divide both sides by 117. Let's try 9. 9 times 7 is 63. 9 times 1 is 9, plus 6 is 15. 9, 10, 53. Sweet. So x is 9. So x is 9, and then hg is 9 minus 2 equals 7. Hopefully that made sense. If not, come and see me during lunch. So basically the same thing here. Notice we have R, so we have RS right here, and that is matching up with RC. So we have these two matching up, and then those two matching up. So if we go 21 over 27 equals 8x minus 8 over 72. Okay, so I'm done doing multiplication and long division. So I'm grabbing my handy dandy calculator so I can find it. Got it. So we end up with 27 times 8x minus 8 equals 21 times 72. And apparently that calculator's not working. So go get my other one. So 27 times 8 is, so we have 216x minus 216. Then we have 21 times 72 equals 1,512. So from here on out, well, actually from here on out, it's algebra. So we're going to add 216 to both sides. There's 216x equals 1728. Divide both sides by 216. We get x equals 8. Okay, so x equals 8, but remember we're not done yet. Hey, no one up there. So we got to plug an 8 in there. 8 times 8 is 64. Minus 8 is 56. So we know RS equals 56. And those are our answers. On to 15. So they actually give you more knowledge than you need here. You could either go 56. So there are two different ways to do this. You go 56 over 35 equals 8x over 20. Notice how we go the bottom of the big triangle versus the bottom of the little triangle versus this side of the big triangle versus this side of the little triangle. Or, you know, you could go 20 over 8x equals 30 over 48. I'm not going to do both of them, but you get the same answer. So 8 times 35 is 280, I believe. Let me double check. Yeah, 280. So you have 8, so we cross multiply. So we have 8x times 35 equals 20 times 56. So we have 280x equals 11200. So we're going to divide both sides by 280. So we have 1120 divided by 280. We get 4. So x equals 4. When we plug that in for TR, we're going to get 8 times 4, or 32. And that's going to be your answer. On to 17. Oopsie, what just happened? So this is proportionality within a triangle. Remember, if we have the angle bisector right here, that these are proportional to these. So we have 25 over 20 equals 3x minus 10 over 16. And again, we're just going to cross multiply. So we have 20 times 3x minus 16 equals, it's a 10, isn't it? Yeah, it's a 10. Equals 25 times 16. Make sure you distribute always all the way through. So it's going to be 60x equals 60x minus 200 equals 400. We're going to add 200 to both sides. So we're going to get 60x equals 600. Divide by 60. We get x equals 10. We then plug that 10 back in there. We have 30 minus 10, or 20. So that's going to be our answer. The side length is 20, and x equals 10. On to 19. Now, don't get confused here. This is exactly the same thing. Really doesn't like me. Okay. So again, we're just going to relate these two. Now, this is tricky, and I don't think you have anything like this on your final, but I'll show you anyway. Notice that these, the 20 would go right here, right? So whatever is equal or proportionate to the 20 would go in that missing spot. What we have over here is 13x minus 3, the whole side, as a relation to that little bit right there. So we want the whole side over here, but we don't want the 20, we just want the little bit right there. We know that if this is 20, this has got to be 8. Cross multiply. So we have 8 times 13x minus 3 equals 28 times 14. Distribute the 8. And 28 times 14 is 49 times 8. So 30, 390 something. 392. I'm going to add 24 to both sides, just basic algebra from here on out. We get 104x equals 416. Divide both sides by 104. And we get x equals 4. Remember, we're not done yet. We got to plug that back in. So 13 times 4 minus 3 That gives me 52 minus 3, or 49. So x equals 4, and then 49. That was number 19, so we're on to 21. Find the missing side length of each triangle. Leave your answers in simplest radical form. Okay, so remember, these are right triangles. Two things should we always think about when we deal with right triangles? The first is the Pythagorean theorem. A squared plus b squared equals c squared. And remember, in order for that to be true, you've got A, B, C, where C is always the hypotenuse. So if we were going to do this, it would look something like this. Now, in your notes somewhere, you should have solved versions for this for each side. So here, we're looking for A. So that's going to be, we're going to use this piece right here. We have x equals the square root of 15 squared minus 1, the square root of 170 squared. Now notice when we square a square root, it just disappears. So 15 squared is 225 minus 170. So x equals the square root of 55. There's no simplifying that. We have the square root of 55 over here would be 5 times 11. Both of those are prime numbers, so there's nothing doing. So x is the square root of 55. Let's look at 23. Again, let's call this ABC. Notice here, it really doesn't matter whether you pick A or B. I'll just show you. So if I was going to do it for A, I'd have x equals the square root of the square root of 257 squared minus 13 squared. If I was doing it for B, I'd go, oh, that's x equals c squared minus a squared. Square root of 257 squared minus 13 squared. So it's the same thing. This is square root of 257, because those cancel out, minus 13 squared, 169. 257 minus 169. Looks to be 88. I'm going to double check my math real quick. Yep, 88. So we have the square root of 88. Now, unlike 55, 88 can be simplified. So we have the square root of 88. That's going to be 2 times 44, which is 2 times 22, which is 2 times 11. Notice we have a pair of 2's here, so we can rewrite that as 2 radical 22. And that's going to be our answer. Remember, it says leave your answers in simplest radical form. A lot of the questions you have on the final are going to be multiple choice. So if you can't go from one to the other, that's going to be problematic. If you want to know a little cheat for that, come and see me. I'll let you know. State of each is a right triangle. So I'm going to do both of these right now. I'm going to do 24 and 25 just to show you how those work. So what we're saying is this a right triangle right here? So if so, this would be A, this would be B, this would be C. So we'd have 5 squared plus the square root of 170 squared equals 14 squared. All right triangles follow the Pythagorean theorem. So if it follows the right triangle, if it follows the Pythagorean theorem, then it's a right triangle. It's a two-way street. 25 plus 170 equals 196. That gives us 195 equals 196. That is not true, so no, that's not a right triangle. Here, we're going to have 2 radical 21 squared plus 3 squared equals 10 squared. This is going to be 84 plus 9 equals 100. So that's going to give us 93 equals 100. So again, no. Now notice what I did here. So if I have 2 radical 21 squared, That's the same thing as 2 radical 21 times 2 radical 21. So that's 2 times 2 times the square root of 21 times the square root of 21. 2 times 2 is 4. 21 square root of 21 times the square root of 21 is 21. 4 times 21 is 84. On to number 27. Find the missing lengths. This is a 45, 45, 90 triangle. You guys should have your flow charts in your notes. Okay? So here we're given the hypotenuse. So we have 4 radical 6 over 3. If I looked at my flow chart, it would say when given the hypotenuse, divide by the square root of 2, or rather multiply the square root of 2 over 2. And so this is going to give me 4 radical 12 over 6. Okay? So the square root of 12 is 2 times 6, 2 times 3. So it's going to give me 2 radical 3. So this is now going to become 4 times 2 radical 3 over 6. 8 radical 3 over 6. And we can pull a 2 out of each one of those and get 4 radical 3 over 3. Now when I say pull a 2 out of each one of those, this is what I mean. If I have 8 radical 6 over 6, I can write this as 2 times 2 times 2 times the square root of 6 over 3 times 2. Notice that I have a pair of 2's there. So when I say I can pull a 2 out, that's what I mean. 2 divided by 2 is 1. 1 times anything is itself. So then I just multiply across. 2 times 2 times the square root of 6. 4 radical 6. On the bottom, it's just 3 times 1. So we get 3. Note, sometimes if everything cancels out, that just leaves you with a 1. 29. So this is a 30, 60, 90 triangle. So they give us the short side here. So to go to the long side, we take the short side and multiply it by the square root of 3. So this turns into 9 radical 3 over 2. To go from the short side to the hypotenuse, we just multiply by 2. So 9 over 2 times 2 equals 9. Boom. 31. Okay, so this is trigonometry. So whenever you start seeing the trigonometry stuff, if I were you, I'd write down my cheat SOHCAHTOA. Okay, so this is 75, so that's where we're going to put Andy. Where does it sit? Because this is our reference angle. Where does Andy stand? Hypotenuse and adjacent. So if that's hypotenuse and adjacent, this is the sine, or that's the opposite. Sorry, guys. So now we have our angle here, 75, and we have these two sides that we're trying to compare, opposite and hypotenuse. When I look up here, I see that that's the sine. I know that sine equals opposite over hypotenuse. So the sine of 75 is going to be x over 18. I'm going to multiply both sides by 18, and that's going to be my answer. X equals 18 sine 75. Grab a calculator. All you have to do is type in 18 sine 75, hit enter. You should get 17.4 because it says nearest tenth. Okay. 33. Again, this is where we're going to put Andy. That makes this hypotenuse, this adjacent, this opposite. Again, our angle's right here. We're dealing with opposite and hypotenuse. So that is sine. So we have the sine of 53 equals 18 over x. Notice now that our x is in the denominator. Again, this is something I showed you how to do. So when I have the x in the numerator, I do the known side times the trigonometric ratio. When what I'm looking for is in the denominator, I go x equals known side divided by the trigonometric ratio. So all we do is we go 18 divided by the sine of 53, and that's going to give us 22.5. 35. So I'm going to show you something. So I know that the relationship between these two, because this is a 30, 60, 90, this is my long leg. So I can go 14 times the square root of 3 over 3, or 14 radical 3 over 3. If I were to put that into a calculator, I get approximately 8.1. Okay? So now what I'm going to do is I'm going to put Andy right here. Hypotenuse, adjacent, opposite. So we're looking at opposite and adjacent. That's tangent. Remember, it's TOA. Tangent is opposite over adjacent. So we have the tangent of 60 equals opposite, 14, over adjacent x. We switch positions here, so we have 14 over the tangent of 60. Drop that into our calculator. And lo and behold, we get 8.1. Level 1 of plane comes together. Can't do that on this one. It's 33. But again, we're going to put Andy right there. This is the hypotenuse. This is the adjacent. This is the opposite. So we're dealing with opposite and hypotenuse. Again, that is sine. So we have the sine of 33 equals x over 18. Multiply both sides by 18, and we get 18 sine of 33 equals x. Drop that in the calculator, and we get 9.8. $39. So now we know we have the angles, or we have the sides, but we don't have the angles. So this, we have A and H. So that's cosine. So we know the cosine of this angle equals 15 over 18. So what you do is you grab a calculator and you say, okay, second cosine, what is the inverse cosine of 15 over 18? So what this does, it asks your calculator, because if sine, cosine, and tangent have a, basically for our purposes, a one-to-one relationship with their angles. Okay? So if we know what the sides are, we can figure out what the cosine is. If we know what the cosine is, we can figure out the sides. And if we know what the sides are, we can also figure out the angles. So we're going to go second cosine, 15 divided by 18. And when you do that, you should get about 33.6. Let me double check. Yeah, 33.6 degrees. But it says to the nearest degree, so we go 34 degrees. 41. Same thing. We're going to go here. This is hypotenuse, adjacent, and opposite. So O and H, so that's sine. So we go the sine of x equals 23, opposite over hypotenuse, which means that x equals the inverse sine of that. So again, on our calculator, we're going to hit second sine, and then just 23 divided by 26. Enter. And let's give you 62.2 degrees or 62 degrees. Here again, hypotenuse, adjacent, opposite. Since we're dealing with opposite and hypotenuse, that's sine. We go the sine of that angle equals 31 over 47, or the angle equals the inverse sine of 31 over 47. I'm not sure what I just did. Okay, so we go that gives us 41.26 degrees, or just 41 degrees. Again, here we are. This would be hypotenuse, adjacent, opposite, opposite and hypotenuse. That means sine. So x equals the inverse sine of 4 over 12. And that's going to give us 19.47 or 19 degrees. And that appears to be it. If you have any questions, let me know. Hope this helps, guys. Study it, know it. This is all you get to take with you into the test. Not the video, but the actual worksheet.